We're going to talk about isotopes. We mentioned a little bit Dalton's atomic theory, where he said that all atoms of the same element were identical, and that's not quite true. It is true that all atoms of a given element have the same number of protons, and they'll have the same number of electrons, but the numbers of neutrons can vary a little bit. And so when you have two atoms that have the same number of protons, they belong to the same element, but if they have different numbers of neutrons, then we call them isotopes. So there's a new word. Iso is a prefix that means the same. So these guys are the same but different. So they have the same number of protons, but they have different numbers of neutrons. And many of the elements have isotopes. Now, the number of, percent, it's easier to talk about it in terms of percent. It's not necessarily split 50-50. So carbon has 3 different isotopes. There's one with 6 neutrons and 7 neutrons and 8 neutrons. But it's not split evenly. And we can't just look at the periodic table and predict which isotopes are naturally occurring. Each element, though, does have its own natural abundance of isotopes. And so if you look at carbon that you isolate from compost here in Tulare County and you compare it with carbon that you got from burned wood in Egypt, the percent abundance of each of the isotopes will be pretty much the same. So all elements have their own natural abundance, and that's pretty much constant throughout the globe. Here's an example with neon. And a neon light is this orange color, and that actually has neon gas in it, and that's a distinctive color of neon. But we're not that interested in that right now. We're looking at what's over here. So neon has 3 different isotopes. And when we say neon 21, 21 is the mass number, the number of protons plus neutrons. So up here, neon 21 has 10 protons and 11 neutrons. Neon 20 has 10 protons and 10 neutrons. They all have 10 protons because they are neon. That's what makes it neon. But they're slightly different in the number of neutrons. So neon 21 comprises only 0.27% of naturally occurring neon. Neon 22, can you see the different colors there? Yeah, because on mine they all look blue. On my computer they all look blue. So these green ones are the neon 22. 9.75% are that, and most of it is neon 20, a little over 90%. These are called the natural abundances. And so each element has its own distinctive percentage distribution of those. So we have, of course, a shorthand symbol for indicating the different isotopes. And here, this is kind of giving you the big picture here. We use the chemical symbol, the element symbol, and unlike the charges on ions, which we put on the right side, we're going to indicate things pertaining to the isotope as a superscript and a subscript on the left side. On the top, we're going to put the mass number, which is the protons plus neutrons, and on the bottom is the atomic number, which is the number of protons. So in the previous example with the 3 neon isotopes, they are all neon, so they all have the element symbol Ne, and each of them has 10 protons because neon is element number 10 in the periodic table. All neon atoms have 10 protons. What's different is the mass number. And so this is the number of protons plus neutrons. And the way I look at this, it's stacked up like it's ready to be subtracted. See that? So we could just go like that. 20 minus 10 is 10, and that would be the number of neutrons. And so this guy over here, neon 22, 22 is the mass number, protons plus neutrons. If we subtract the number of protons, we get the number of neutrons. The mass number A is the sum of the protons and the neutrons. Because there were 3 subatomic particles that we talked about inside the atom: protons, neutrons, and electrons. The electrons were so tiny that we said we don't even really need to think about their mass. It was just too small. And so the ones that have mass are the protons and neutrons. So the mass number is the number of massive particles. The difference between the mass number and the atomic number gives us the number of neutrons. Another way to indicate isotopes is by using the chemical name or the symbol followed by the mass number. So the neon isotopes would be Ne20 or neon 20, Ne21 or neon 21, Ne22 or neon 22. The mass number is what tells us which isotope it is, because they all have the same number of protons. And we don't really need to specify that in our notation, because all we have to do is look at the periodic table. But this gives us the approximate mass of those atoms, those different isotopes. Okay, so let's do an example. What are the atomic number, the mass number, and the symbols for the chlorine isotope with 18 neutrons? Well, they're telling us that it has 18 neutrons, and this is chlorine, so we can find out how many protons it has from the periodic table. Chlorine is element number 17. That means it has 17 protons. So what's the atomic number? The atomic number is the number on the periodic table, the number of protons. So the atomic number here is 17. The mass number is where we add up all the particles that have mass, significant mass, which would be the protons and the neutrons. So we're going to add these two together. 8 and 7 is 15, carry the 1, 35. Go ahead and use your calculator, I'm just being lazy. So the mass number would be 35. The symbols, plural. Well, there's a couple of different kinds of isotope symbols. One is to do the element symbol followed by the mass number, which is 35. Or we could use the element name followed by the mass number. Or we could do the one with the superscripts and subscript. How do you remember which one to put on the top? Remember, it's stacked up to subtract. Put the big one on top and the little one on the bottom. So it's 35 up here and 17 down there. So there's 3 different symbols for that isotope, all referring to the same thing, just different ways of representing them. Any questions? This isn't really hard, it's just new and different. Personally, I'm not a fan of new and different, so unless it's my idea, then I'm fine with new. How many protons and neutrons are in the potassium isotope? And they give us this symbol, K with a 39 and a 19. Well, how many protons? 19. There's 2 different ways you could know that. You can look at this symbol and say, oh, there's the number of protons right there. 19 protons.
Protons are always going to be on the bottom?
Protons are in the bottom, yeah. This is a messy 9 protons. Or potassium, you find it on the periodic table. It's element number 19, and so you can tell it that way. How many neutrons? 20. Right? So this is the mass number, 39. Atomic number is 19. We just subtract. And that's the number of neutrons. So 19 protons, 20 neutrons, that's the answer. There is no shortcut, easy way to predict how many neutrons an element has from the periodic table. Some elements have 2 major isotopes, some have 3 or more, some only have 1. And it's just, there's no real predicting. But we give you enough information in a problem that you can figure out the required things. Any questions?
So we always subtract for neutrons?
Yeah, because this is the mass number, which is the protons plus neutrons. And if you subtract the number of protons, then you're left with the number of neutrons
And we add for the neutrons and protons for mass.
to get the mass number. So the mass number is the number of particles that have a significant mass. So that doesn't include the electrons, because they were like 2,000 times smaller. So throwing in 19 electrons, which are there, doesn't really affect the mass at all.